Alright, so today what we're going to do is really just go over what we have gone over the past 2 days. But in addition, we're going to talk about some of the names that we call the certain things, certain characteristics on a quadratic function. Alright, so on the first one, okay, if we look at it, we need to decide whether this is in vertex form, root form, or standard form. Now hopefully by now you should be able to recognize that when you look at one like that, it's in standard form. Alright, so the first thing we're actually going to do is we're actually going to say, we're going to go through the formula. If you remember, we're going to say that the a is 1. Remember, this is this one right here, this coefficient that's understood. We have b is 4, and we have c is 3. Now remember that c is equal to 3 is actually your y-intercept. So that actually helps you to check to see if you did this right. Alright, so we're going to put our y-intercept right there. That's, if we have a standard form, we know that's for sure. And that only happens in standard form. Okay, so what we're going to do after that is we're going to go through that formula that we have talked about in the past. And you don't need to memorize it or anything, but this is going to be negative b over 2a. In this case, b is 4, so we have negative 4 over 2 times 1. Now this is going to be negative 4 over 2, which is going to give me negative 2. Okay, so remember that what I just found is the x-coordinate of the vertex. Okay, now to find the y-coordinate, don't forget that what we do is we're going to grab y, the y-coordinate. Really all we're doing, and I'm writing probably too much, but all we're doing to find the y-coordinate is plug in this negative 2 back into this. And whatever we get, well, that's the y-coordinate. Now the formula says this, which who cares? That just means that, remember, the negative b over 2a, we find that out that it was negative 2. So if we plug in negative 2, we'll find out what the y-coordinate of the vertex is. So we have y is equal to negative 2 squared plus 4 times negative 2 plus 3. Now remember, what we're doing here is we're actually looking at this and plugging negative 2 for every x. Now, when you do some of this math, it turns out that you get negative, you get negative 1, yes. Okay. So again, let's see, it's going to give you a 4 minus 8. It's going to be negative 4 plus 3, yeah. So this is negative 1. So my vertex is going to be negative 2, negative 1. Now, I think I have everything I need. Alright, so negative 2, negative 1 is located right here. Now if you look at this, because there's no number in front of the x squared, this is not being stretched or reflected. So therefore my points, if you remember, were 0, 0, which I'm going to pretend like this point right here, that point, is 0.00. And if you remember all those numbers, 1 squared is 1. If x is equal to 2, y is equal to 4. Now I'm pretty sure I did this right, because when I went over 2 and up 4, that's my y-intercept, which I knew from the beginning that it was. Alright, so this is my axis of symmetry, right where the vertex is located, and then I have those points right there, those coordinate points. Now I'm able to come back to this, therefore, and fill all this out. Now remember that the axis of symmetry is actually the x-coordinate of the vertex. Now you may not remember that, but remember that it's this line right here. This is the axis of symmetry. And it happens to cross right through x is equal to negative 2. Now when it's asking for the maximum or minimum value, what is really asking is, what is the y-coordinate of the lowest or highest point? Now in this case, we have a low point, which is negative 1. The y-coordinate is negative 1. Again, and if you're catching on, notice that the vertex is, the y-coordinate of the vertex is, in this case, the minimum value. Now there is no maximum value, because if you look at this arrows that I put on here, there is no maximum, because that goes towards positive infinity. Now if you remember from the past, the domain of this, as you look, as this graph gets higher, it covers everything to the right, and as it gets higher on the left, it covers everything to the left. So the domain for all of quadratic functions in this case is going to be all real numbers, which if you remember that meant from negative infinity to positive infinity. That's what that means. Okay? Now the range, we're looking at the lowest point and the highest point. Now the lowest point, we already talked about it. That is y is equal to negative 1. So we can either write it as y is greater than negative 1 because negative 1 is the lowest point, and then it goes up towards towards the top, towards the north, if you will. So again, the lowest point is negative 1, and it keeps going up forever. So you can either write it like this, or you can write it like this, from negative 1 to positive infinity. It doesn't matter, just make sure you put open parentheses with the infinity. And then finally the roots, remember that the roots is the same thing as the x-intercepts, right? So all you have to do is look at the graph and see where it crosses the x-axis. In this case, it crosses right through negative 1 and negative 3. So we're going to write that our roots are x is equal to negative 1 and 3. Okay? Okay, so again, same type of problems, except for we're talking about more of the characteristics of all of the quadratic functions. So on this one right here, if you notice, this is in vertex form. Now this one's going to be a whole lot easier because if this is the vertex, remember it's going to be the opposite of this number. Now if you're wondering why I put a 0, well that was kind of understood. If I don't have a y-coordinate there, that must have meant that the y-coordinate was 0. Alright, so the vertex is going to be located at 2, 0. Okay, now because this is my vertex, that means that my axis of symmetry is actually going to be located right through that point. Alright, so my axis of symmetry is also going to be x is equal to 0. Now finally we're going to look at this, and if you remember this, this is a 3 is going to make this a vertical stretch. So what that means is that my first point is going to be to the right one. Remember, the x's don't change in the problems that we're doing. But what we're going to do here is that this 3 is going to stretch this by a factor of 3. So that's going to be that point right there and that point right there. Now, we could probably plot more points, but we're just going to leave it like that because that's all we really need. Now, if you look at it, on this one, because this is a parabola opening up just like the last one, you have a minimum value. Not a maximum, a minimum. Only a minimum value. The maximum, well, it's positive infinity. So we're going to say that our minimum value is y is equal to 2. And sorry, I just noticed that I put x is equal to 0. I meant to say, I got this backwards. I apologize. So the axis of symmetry is x is equal to 2. And the minimum value is y is equal to 0. Now the domain is going to be all real numbers. And remember, feel free to write it the other way if you want to. And the range is going to be from the lowest point, in this case is going to be 0. And because it's going up, up is greater. So we're going to have y is greater than or equal to 0. Right, now finally the roots. Well, these are the x-intercepts. Now a lot of the times we say, well, it's where it crosses the x-axis. Well, in this case, it doesn't actually have to cross. It just has to touch the x-axis. And this is actually called a double root, but whatever. Just look at the coordinate, the x-coordinate of that point, which in this case is x is equal to 2. All right, so again, this is the vertex form. Now, finally, number 3. Now, on number 3, if you look at it, this is in root form. Okay, so this is in root form. So that means that my roots, which are my x-intercepts, are going to be located at x is equal to 2 and positive 2. So we have negative 2 and positive 2 as my roots. Right, remember that technically I'm taking the opposite of those two. So this is positive 2, that's negative 2. For reasons that we'll probably talk about later. So we're going to put our roots here. We have positive 2, negative 2. Now on this one, my axis of symmetry, remember that when you have something in root form, my axis of symmetry, which is going to give me my vertex, is located right between those 2 points. Alright, so I'm going to draw this red line in this case, so hopefully you can see it, that's my axis of symmetry. Alright, my axis of symmetry, remember that a vertical line is x is equal to, in this case, x is equal to 0. Alright, because this is 0, even though I know this is the y-axis, but this is the vertical line, x is equal to 0. So that actually gave me, that's the x-coordinate of the vertex, because remember that my vertex is located right on this line, on the axis of symmetry. My axis of symmetry is x is equal to 0. At least I know that much. Okay, to find out my y-coordinate of the vertex, all I have to do is plug in this coordinate, 0, into this x and that x and see what I get. Alright, so we have y is equal to negative 2, 0 minus 2, 0 plus 2. So we have negative 2 times positive 2. So y is equal to positive 8. So my vertex is going to be located at positive 8. Now, even without you even knowing what that means, notice that I know I did this right because this is a negative 2, which means that you're being reflected. And in this case, you are if you just connect those dots and hopefully make them look like a parabola. Alright, so that's all I need. Now we can go over the points. Yes, it's being stretched by a factor of 2, so it's going to be over 1 down 2. You can put this on there, but that's all I need for now. Now this one's the opposite of the other two. On this one, we have a maximum value. We have this little peak right here. That's the maximum. Now on this one, we don't have any minimums because the parabola goes infinitely down. Okay, so we have our maximum value is located at y is equal to 8, which is the y-coordinate of the vertex. Domain, that's not going to change. That's all real numbers. Remember, the domain is basically how far to the right and how far to the left does this function go. And in this case is from negative infinity to positive infinity, which we call all real numbers. Now the range, we're talking about how high and how low does this graph go. Now the highest this reaches is 8, so we can, I usually prefer to write it like that. I put y and I leave some space and I put an 8. Then all I have to decide is, because this is pointing down, down is less than, so we have less than or equal to 8. So again, the highest point is 8, the lowest one, well, we don't know. Alright, so, well actually we do know, it's negative infinity, but we're just going to write it as y is less than or equal to 8. Now the roots, well, the roots we already knew from the very beginning because that's what was given to us. That's negative 2 and positive 2. Alright, this homework is about the same as the other ones. This could take a little bit of time. Now, let me do one quick example on your homework. Let's go over question number 3 on your homework. Alright, so quickly let's do this one. Alright, so on number 3, now if you look at it, it might be kind of difficult to tell what it is, but this is actually a standard form. Now we don't have a number here, but if we don't have a number, we can actually write plus 0. So in this case, A is negative 2, B is 4, and C is 0. Now remember that this 0 represents that this is the y-intercept. So we can actually come here and put our y-intercept, and that more or less kind of helps us to know if we did this right later on. Okay, so if we look at it, let's see. I'm going to do it down here, so well, let's do it over here. We have, well, I'm going to do it down here, sorry. We have x is equal to, remember that formula, negative b over 2a. Anytime you have a standard form quadratic, you need to use this to find the vertex. In this case, that's going to be negative 4 over 2 times negative 2, which is negative 4 over negative 4 is equal to 1. Alright, so what that means is that's the, excuse me, the next there instead of a 1. Let me erase that. Alright, so what that means is that the x-coordinate of the vertex is 1. Now to figure out the y-coordinate, remember all you're doing is plugging in this case, a 1 for x. Alright, so we have negative 2 times 1 squared plus 4 times 1. Well, you can write plus 0 if you want to, but it's not going to change anything. So that's going to give me negative 2 plus 4, which is 2. So again, find the x-coordinate by using this formula, and after that just grab the x-coordinate and plug it in for x, and that will give you y. So in this case, vertex is 1, 2. Now that I have that, I can actually plot my vertex here. My vertex is located right here, and if that's my vertex, remember that this is my axis of symmetry that runs right through that. Alright, so my axis of symmetry is x is equal to 1. Okay. Now, to fill out the rest, if you look at this, this is being reflected, and it's also being stretched by a factor of 2. So, if you remember the points, if I pretend that 0, 0, my first point would have been 1, 1. But because I have a negative 2, my point is now going to be 1, negative 2. So 1, negative 2. And it looks like I did it right because this other point, it's a mirror image of this one. So it looks like I did it right. So now I have my roots, I have everything I need. So my maximum value in this one, remember I have a maximum, not a minimum, because we don't have a minimum, the minimum would be negative infinity. So the maximum value in this case would be y is equal to 2, which is the y coordinate of the vertex. Domain, as always, for all of these is going to be all real numbers. The range is y. Well, I'm going to leave some space, and I'm going to put a 2 here. Or that's the y coordinate. That's the y coordinate of the vertex. Now I'm going to decide now, because this is pointing down, that's going to be less than or equal to. Okay. Now as far as the roots go, well, just look at the graph. If you did it right, the roots are going to be 0 and 2. So roots are going to be x is equal to 0 and 2. Alright, please work as hard as you can on this. I know I'm not here. If you got any questions, you can feel free to ask other teachers. However, you can always, if you have a Twitter account and you really want to do this, you can always reach me at Mr. Ochoa Algebra 2. That's my Twitter handle. So if you need any help, you can take a picture of the problem, you can send it to me, and as soon as I get a hold of it, I will do my best to try to answer your question. I'm hoping to have a quiz after this. We'll see how you do. Good luck.